Hi, let's see this question which is based on tree diagram and probability. Let's read the question. Sharon, Christine and Keith have agreed to meet at a restaurant for lunch. Sharon has probability zero point 0.8 of being on time. Christine has probability zero point 0.7 of being on time. Keith has probability zero point 0.4 of being on time. Draw tree diagram to display the possible outcomes. So we have here three sets of information that is about Sharon, Christine and Keith. So at first I'm going to start with the information I have for Sharon. There are two possibilities. So Sharon will be on time or he will be late. I'll write the probabilities later on. First I'm going to write this information. So if Sharon comes to the restaurant on time, then for the second friend, we have two possibilities. Christine could be on time or Christine will be late. These are the two possibilities. After Christine, let's write this data for Keith. So if Sharon is on time, Chris is on time, Keith could be late or he could be on time. If Sharon is on time, Christine is late, Keith could be late or on time. So far I have listed down all the possibilities. When Sharon is on time, Chris could be on time or late. If Chris is on time, Keith could be late or on time. If Chris is late, Keith could be late or on time. So I have covered all the possibilities when Sharon is on time. Now let me write the possibilities when Sharon is late. If Sharon is late, Chris could be on time or Chris could be late. These are the two possibilities. If Chris is on time, Keith could be late or Keith could be on time. If Sharon is late, Chris is also late. Keith could be still be late or on time. I have listed down all the possibilities here. Now I'm going to write the probabilities for all this. So Sharon has probability zero point 0.8 of being on time. So I will mention 0.8 here. Total of Sharon being on time or being late should be 1. Probability of happening of an event plus probability of not happening of an event is always 1. Because event will either happen or it will not happen. So altogether, surely one of the things will happen. So Sharon will be on time or he will be late. Let's solve the second part of the question. Determine the probability that at least 2 people will be arriving on time. So at least 2 people means minimum 2 people should be on time. It could be 3 or it could be 2, but it cannot be less than 2. I'm going to just cover the top part of the question because I don't have space on the board. Let's solve it on top. Determine the probability that at least 2 people will be on time. So I'm going to use T for on time and L for late, and the order would be Sharon, Chris and Keith. These are the scenarios. Probability of Sharon on time, Chris on time and Keith on time. Covers are at least 2 people will be on time. Or we have Sharon on time, Chris late and Keith on time. Or Sharon arrives on time, Chris is also on time, and Keith is late. We have covered all the scenarios of the top branch where Sharon is on time. Now let's have a look at the second branch, which is when Sharon gets late. So Sharon gets late, Chris is on time, and Keith is on time. This covers all the scenario in which at least two people will arrive on time. We cannot take other scenarios because at least two people should be on time. So this is what we are going to use. For or, we add the probabilities, and wherever you see and, we multiply. So what you're seeing inside the bracket, it is and. Probability of Sharon being on time, Chris being on time, and Keith being on time. Or Sharon will be on time, Chris will be late, Keith will be on time. Or Sharon will be on time, Chris will be on time, and Keith will be late. Or Sharon will be late, Chris will reach on time, and Keith will reach on time. In all these four scenarios, we'll have at least two people arriving on time. So I'm now going to write the expression. Sharon will be on time. Probability is 0.8 in our diagram. It is given to us. So I've written it there. And Chris is on time, which is 0.7. And Keith is also on time, which is 0.4. So this is one case. Or Sharon will come on time, Chris will be late, and Keith will be on time. Or Sharon will reach on time, and Chris will also be reaching on time, and Keith is going to be late. In the last case, plus Sharon comes late, Chris arrives on time, and Keith is also on time. So I've got all the probabilities in place here, which covers our scenario. And when you do it manually, or if your board allows use of calculator, use calculator. Result of this calculation will be 0.712. This is a probability that at least two people will arrive on time. If you're using your calculator, make sure you have these brackets when you plug in the information in the calculator. So this question is done.